Okay, so before we continue to parts E through H, where we look at increasing, decreasing, and concave up and concave down, let's try to visualize what we're dealing with in terms of this function. So we can graph it. So my function is x cubed plus 12x squared minus 60x plus 1. Okay, so let's graph it. So the graph doesn't fit on the screen, so we need to change our viewing window. And we also know that one of the critical points is at -10, so probably we want to extend the graph a little bit more to the left. So let's go from -15 to +5. And again, we can't see it, so let's try -100 to +100 for the y values. Now let's graph it. Okay, so we see the minimum here at x equals 2, which we identified previously, but we don't see the maximum because it's still outside of the viewing window. So we probably have to increase the y value by a lot, so let's say 500. Okay, so we again still see the minimum at x equals 2, the maximum, it's outside the window still. So let's try to go all the way to 1,000. And maybe I changed the hash marks to go by hundreds because of the value range here. Okay, so now let's graph it. Okay, so we see we have a local maximum here at x equals -10 and a local minimum here at x equals 2. And to be sure, we can calculate this, right? So let's calculate the max. At this point. Right, so we see we have a maximum at x equals -10, and similarly we can calculate that the minimum occurs at x equals 2. Okay, so going back to problem 7. So now we want to look at where it's increasing, decreasing, concave up, and concave down. Right, so visualizing in terms of the graph, we can already see that it's increasing in this region here, is decreasing in this region here, and it's increasing in this region here. And then also you can see that this portion of the graph has the concave down shape, and then this portion of the graph has the concave up shape. So we want to calculate these features that we're seeing in terms of the graph. Okay, so increasing and decreasing comes from the first derivative, so we need to use the first derivative here. And where it's increasing and decreasing, right, so it's separated by the critical points, right? You see it's increasing, and then it hits the critical point, and then it's decreasing, and then it hits the critical point, and then it's increasing. So to identify the intervals, we need to separate the x-axis using the critical points. So let's visualize it here. Right, so this is the x-axis from -infinity to infinity, and it's separated by the critical point. So this is +2. Okay, so now once I've separated the x-axis, what I want to do is I want to choose some test points within each interval, right? So say within here, within here, and within here. So in between them, I can choose x equals 0. And then here I can say choose x equals -11. So it doesn't have to be any particular values as long as it falls within the ranges for each interval. And then here I can say choose x equals 3. Okay, so again, what I'm looking for is whether the first derivative is positive or negative, and then that'll tell us whether it's increasing or decreasing within each interval, right? So let me write down the different intervals, right? So the first interval is from -infinity to -10. This interval is from -10 to 2, and this interval is from 2 to infinity, right? So each of these 3 separate intervals here. Okay, so let's do the calculation. So I'm plugging it into the first derivative, right? So let's write that down again. Whoops, the first derivative. So that was calculated previously as 3x squared plus 24x plus -60. Okay, so I do it separately for each of the x values, right? So let's plug in x equals -11, right? So it's 3 times -11 squared plus 24 times -11 minus 60. So let's calculate that. Three times -11 squared plus 24 times -11 minus 60. And the result is positive 39. So that means that this x value, which was for this interval, the derivative is positive, so that means that this interval is increasing. Okay, so I want to calculate similarly for the other x values. So f prime of 0, so I just plug in x equals 0, so 3 times 0 squared plus 24 times 0 minus 60. So this is just equal to -60. And this was for the middle interval from going from -10 to +2. And so the derivative is negative, means that the function is decreasing. And then finally, I plug in x equals 3. So 3 times 3 squared plus 24 times 3 minus 60. So let's calculate this. Okay, so I get positive 39 again. So the last interval from 2 to infinity, derivative is positive, so the function is increasing. Okay, so now I can write down the answer. So let me write the answer in purple. Right, so where is it increasing? It's increasing in these two intervals. So let's write that down, right? So minus infinity up to -10, and then union the other interval from 2 to infinity. Okay, and then where is it decreasing? It's decreasing in the middle interval here from -10 to +2. Okay, so that's the first derivative. It tells us where the function is increasing or decreasing, and again it matches with what we see in the graph, right? So increasing from -infinity up to -10, right? So that we're talking about the x values here, and then it's decreasing from -10 up to +2, and then it's increasing from 2 to infinity. Okay, so now we want to do the same thing for concave up and concave down. So concave up and concave down is coming from the second derivative, right? So we want to look at the second derivative, which is 6x plus 24, and the inflection point is when we set this equal to 0 and solve for x. So 6x is equal to -24. So x dividing by 6, you get -4. Okay, so again, the x value that we get will determine our intervals. Right, so the x value is -4. So I choose test points for each interval, right? So say x equals -5 and say x equals 0. So let's identify the actual interval, right? So this interval goes from all the way from -infinity to -4, and then this interval here goes from -4 to +infinity. Okay, so now we calculate with the test points, and when the second derivative is positive or negative, will tell us concave up or concave down. Right, so we plug it into the second derivative, right? So x equals -5, plugging it in. So again, we're calculating with the second derivative, so this equation here, right? So 6 times -5 plus 24, so it's -30 plus 24, which is -6. So negative means it's concave down. And when x equals 0, you got 6 times 0 plus 24, which is +24. So that positive number tells us concave up. Okay, so this test point was for this interval, and this test point was for this interval. So I can say that the interval from -infinity to -4 is concave down, and then this interval from -4 to infinity is concave up. And again, going back to the graph of the function, we can see this occurring, right? So whereas x equals -4, -1, -2, -3, -4, so it looks like the inflection point occurs here, and we see that the region on the left is concave down, and the region on the right is concave up.